Hello everyone, welcome to Into Matheism. So our topic for today is about ellipse. So first, let us define the conic section ellipse. Ellipse is the set of all points x, y in a plane in which the sum of whose distances from two distinct fixed points called foci is constant. So we have here an illustration of an ellipse containing its parts. So let us study this one. This is an ellipse with a center at 0, 0 or at the origin. So our center is here. Next, we have f sub 1 and f sub 2. Now f means focus. So we have focus 1, focus 2. So we have two foci for an ellipse. Next is we have v sub 1 and v sub 2. V means vertex. So we also have two vertices for an ellipse. Next, we also have our co-vertex here, another one is here. And our major axis, our principal axis, from vertex 1 to vertex 2, this is our major axis or the principal axis. This is the longer one. Now the shorter one, from our co-vertex 1 and co-vertex 2, we have our minor axis. So this is a shorter line compared to the major axis. Now, we have here from the center to our co-vertices, we have b units. Therefore, the distance from the center to our co-vertices measures b units. You will understand later what is this a, b, and c if we will study the standard equation of an ellipse. Now, from the center to our vertices, we have a units. So the distance is a units or the value of a. Next is from the center to our focus or our foci, we have c units. Now take note, we have here the center, the foci, and the vertices are all on the major axis. So from the vertex 1 to vertex 2, our major axis is here or the principal axis. So in our principal axis can be located the center, focus 1, focus 2, and the vertices, which is the v sub 1 and v sub 2. So these 4 points, or 5 points rather, are located on the principal or the major axis of an ellipse. Next is, A is the distance again from the center to the vertex of an ellipse or to the vertices of an ellipse. B is the distance from the center to the co-vertices, and C is the distance from the center to the foci of an ellipse. Now lastly, we have here A is always greater than B. So our A is the distance from the center to our vertices. The measurement of the line here from the center to our vertex is always greater than the distance from the center to our co-vertex. So that is A is always greater than B. Now in order for us to get the value of C, because in our standard equation, the only given value is the A and the B. So for us to get the value of C, we will use C squared is equal to A squared minus B squared. Now let's talk about the standard equation of an ellipse. So as you can see here in the board, we have 4 equations. So these first 2 equations are the standard equations of an ellipse if the major axis is horizontal or parallel to the x-axis. So first, we have x squared over a squared plus y squared over b squared is equal to 1 if the center is at the origin or at 0, 0. So that is the illustration. We have here the major axis is horizontal and our center is 0, 0. Next is we have x minus h squared is equal to a squared plus y minus k squared over b squared is equal to 1 if the center of an ellipse is HK. That is, we have values other than 0, 0. So the center is not already in the origin. So we have here, our center is somewhere at the right of the y-axis. So it is not in the origin. So this is the illustration for the equation number 2. These 2 equations are the equations of an ellipse if the major axis is vertical or parallel to the y-axis. First, we have x squared over b squared plus y squared over a squared is equal to 1 if the center is at the origin. So as you can see, we have no h and k here. So our center is at 0, 0. For illustration, our major axis is vertical and our center is at the origin. Next, another, we have quantity of x minus h squared over b squared plus y minus k squared over a squared is equal to 1. It is if the center is at hk. Our illustration, so this ellipse, its major axis is parallel to the vertical axis or the y-axis, and we have here our center at the right of the y-axis, so it is not in the origin. So we have our equation like this. Now question, how can we be able to identify if our ellipse is parallel to the horizontal or the vertical axis given the standard equation? Let us examine these 4 equations. The difference is this first set of equation we have here, the denominator of x squared is a squared. The second set, the denominator of x squared is b squared. So it is evident that in order for us to identify if an ellipse is parallel to the horizontal or vertical axis, we just have to look at the variables here. If the denominator of x squared is a squared, then the ellipse is parallel to the horizontal axis or the x-axis. However, if the denominator of x squared is b squared, therefore the ellipse is parallel to the vertical axis or the y-axis. And always remember that we always have this plus sign here, the addition sign, and not the subtraction sign, which is minus. And our equation is always equated to 1. Now let us study how to graph an ellipse given the standard equation. So we have here our example 1, x squared over 25 plus y squared over 16 is equal to positive 1. So first to do is to determine the position of this ellipse. Now, we don't know here which is our a squared and our b squared. So let us go back to our discussion earlier. We said that a is always greater than b. So it follows that a squared is also greater than b squared. Now, in our denominators 25 and 16, which do you think is greater, 25 or 16? So obviously, the greater one is 25. So therefore, our a squared is 25 and our b squared is 16. So we can see here that the denominator of our x squared is a squared. And if the denominator of x squared is a squared, therefore, the major axis of this ellipse is horizontal. So we have our ellipse is parallel to the x-axis. Next to that, we will get the center of this ellipse. Now, we don't have the values h and k here. Therefore, the center of this ellipse is at the origin. So the coordinates are 0, 0. After getting the center, we will get the values of a, b, and c. So first, we have to get for the value of a. So since our a squared is 25, because 25 is greater than 16, in order for us to get the value of a, we will get the square root of both sides. So cancel, a is equal to positive 5. For our b squared, we have 16. To get the value of b, to get the square root of both sides, so cancel b is equal to positive 4. So we have our a is equal to 5 and our b is equal to 4. In order for us to get the value of c, we will use the formula c squared is equal to the square root of a squared minus b squared. So our a squared is 25. So we will just substitute 25. Our b squared is 16. So we have square root of 25 minus 16 is equal to 9. Square root of 9. C is equal to 3. So we have our values for A, B, and C. So our A is for the vertex, our B is for the co-vertex, and our C is for the focus. Now, let us graph our ellipse in a Cartesian plane. First, we will draw a Cartesian plane. So first to plot is the center of our ellipse. So our center is at the origin. So we have here, center is 0, 0. Since the position of our ellipse is parallel to the horizontal axis, so we can see that our vertices and our focus lies also on the x-axis of our plane. First is we will have our vertex. So A is equal to 5. Therefore, we will count 5 units from the center to the left and to the right. So 1, 2, 3, 4, 5. So we can have here our vertex 1. To the right, 1, 2, 3, 4, 5. We can label it as vertex 2. So we have 2 vertices. This distance is equal to A. So that is 5 units. Again, 1, 2, 3, 4, 5. So that's correct. Next is we will locate our co-vertices. So B is equal to 4. So we have to count 4 units upward and downwards. So 1, 2, 3, 4. Again, downward from the center. 1, 2, 3, 4. So these 2 points are the co-vertices of our ellipse. Next is to locate our foci. So C is equal to 3, so we will count 3 units to the left and to the right from our center. So 1, 2, 3. This is our focus. 1, 1, 2, 3. This is our focus 2. So assigning of points here as B sub 1 or F sub 1 is arbitrary. It means we just can have it as V sub 1, F sub 1, and this one as B sub 2 and F sub 2. It doesn't matter. We can now sketch our ellipse. We will connect the 4 vertices. Okay, so this is our ellipse. Now let us identify the coordinates of our foci and our vertices by just looking at the Cartesian plane. So this is V sub 1. Looking for its coordinates, so we have here negative, negative 1, negative 2, negative 3, negative 4, negative 5. So its x is negative 5 and its y is 0 because it is aligned at 0. Next, F sub 1, we have here negative 1, negative 2, negative 3. Again, its y is also 0. Next is our vertex 2. Our vertex 2 is positive because it is at the right of the y-axis. So we will count from the origin 1, 2, 3, 4, 5. So we have positive 5. Again, its y-axis because they are all straight to 0. So its y is also 0. Our focus 2, we have positive 1, 2, 3. So we have its x is 3 and its y is also 0. Then lastly, we will label our ellipse. We have x squared over 25 plus y squared over 16 is equal to positive. Next example, we have quantity of x minus 2 squared over 64 plus quantity of y plus 1 squared over 100 is equal to 1. So we will determine the position of this ellipse. Okay, so which is our a squared and which is our b squared? Again, a squared is always greater than b squared because we said earlier that a is greater than b. So among the two, 100 is greater than 64. Therefore, our a squared is 100 and our b squared here is 64. So our denominator of x here is b squared, which is 64. We can say that the major axis of this ellipse is parallel to the vertical axis. So we have vertical. After determining the position, we will get the center of this ellipse. So we have here the values of h and k. So we have the center. Our h is negative 2, it will become positive 2. Our k here is negative 1. So our center is 2 and negative 1. Next is, we will solve for the value of a, b, and c. So our a squared is equal to 100. Therefore, our a is 10. Our b squared is 64. Therefore, our b is positive 8. So our a is 10 and our b is positive. To solve for c, we will use the formula c squared is equal to square root of a squared minus b squared. So substituting the values 164, we have square root of 100 minus 64. Because our a squared is 100 and our b squared is 64. So 100 minus 64, the answer is 36. And square root of 36 is 6. So our C is 6. Again, our A is for the vertex, B is for the co-vertex, and C is for the focus. So now let us graph. We have here our Cartesian plane. So first to plot is the center of an ellipse. So our center is 2 and negative 1. So x is 2. So 1, 2, negative 1. Therefore, 1 unit downward. So our center is in the fourth quadrant. Since the position of this ellipse goes with the vertical axis, our vertices and our foci are on this line. So we will count A units upward and downward. So first we will have A is equal to 10. For us to locate our vertices, we will count 10 units upward and downward again because the position is vertical. So from our center, count 10 upward. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Vertex 1. Again from the center, 10 units downward. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have here our vertex 2. For our focus, we will use the value of C, which is 6. Again, our focus is aligned to our vertex on the principal axis or the major axis. So this is our major axis, therefore our focus is somewhere here also. So we will count 6 units upward and downward also from the center. So 1, 2, 3, 4, 5, and 6. This is our focus 1 because we have here our vertex 1. But if you assign it here as vertex 2, you will put here your focus 2 also. So again, downward 6 units, 1, 2, 3, 4, 5, 6. So we have here F sub 2. For our co-vertices, we have 8 units because our B is 8 units. So we will have it to the right and to the left. Because our major axis is vertical, therefore our minor axis is horizontal. So we have 8 units, 1, 2, 3, 4, 5, 6, 7, and 8. 1, 2, 3, 4, 5, 6, 7, and 8. Again to the left we have 1, 2, 3, 4, 5, 6, 7, and 8. We can connect all the vertices of our ellipse. This is our major axis or the principal axis, and this is our minor axis. So this is the major axis and this is the minor axis. Now we will determine the coordinates of our foci and our vertices. So V sub 1, F sub 1, V sub 2, and F sub 2. Since our foci and our vertices are just aligned with our center, we can expect that the x-coordinates of these 5 points are just the same or similar. So, x of the center is 2, therefore the x-coordinates of the foci and the vertices is also 2. So, we can write 2, 2. So, we will just have to find for the y-coordinates of these 4 points. So, v sub 1 is here, so we will count from the origin because we are finding the coordinates. So, from the origin, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, we have positive 9. For x sub 1 from the origin again, 1, 2, 3, 4, 5. So, we have positive 5. For v sub 2 from the origin, we will count 11. This is negative 11. And for f sub 2, we have here, so from the origin we will count 1, 2, 3, 4, 5, 6, 7. So this is negative 7. So these are the coordinates of our vertices and our foci. Again, we have the same x because they are just aligned here in x, which is positive 2. So lastly, we will label our graph. So x minus 2 squared over 64 plus y plus 1 squared over 100 is equal to 1.